Okay, good morning everybody. I'm Gary Hartley from Folsom Lake College. I'm a dean, but I can still present, even though I'm a dean. I mean, deans have limitations, but I'm going to try to, work around that a little bit today. Does this look like what you signed up for, so to speak, by walking in? If not, I'm probably going to try to stay with this theme, although I must admit that if you take out your program and you read the description of what we're going to do, I'm not really going to do that directly, okay, kind of indirectly. So I'm going to try to take you on a little bit of a journey with computational thinking, which is the theme of our grant with NSF, and to give you an opportunity to see how we pulled it off and what we came up with. And I appreciate Deborah and some other folks in the room that also are veterans of the CPATH grants with NSF, so that'll be kind of fun to see what they have to contribute as well. Rules of the game. One thing is that this is a public Prezi. How many of you have used Prezi before? So you're familiar with it? It's kind of a web-based, cloud-based alternative to PowerPoint. So if you haven't seen one before, you'll get to see it today. This is public, so we will make sure that if you give me a card at the end, I'll give you the address so that you can come and view this. And one of my secret ambitions about that is that we'll kind of get out of PowerPoint and more into Prezi and some other tools like that. That I think are a little bit more fun and they're more accessible because you don't necessarily have to take a media device and move it around and that kind of thing. So I'm sort of getting into the whole cloud thing with Google Docs and Google Hangouts. I just like the name with Google Hangouts. I don't know how to use it very well, but I love the name because my boss will call me and say, "What are you doing?" I say, "Oh, I'm hanging out." Okay, but he's wise to me now. Okay, so I entitled this Computational Thinking Changed My Life. That is, once I found out what it was. One of the things that we did in applying for a grant with the National Science Foundation is we sort of bought into this idea that computational thinking might be something that's worth looking at. And we already had a cadre of people that were working together on a community building grant with NSF, so we thought, oh, what the heck, we'll find out what they want us to do with this concept of computational thinking. Interestingly, I think, what happened was, here we go. This is what we found. Have you seen these before? These are what are they called? Tuxedos. But it's kind of this idea of, it's sort of a mess out there, and this represents the United States of America, and 48 of them anyway. And just sort of all this stuff happening out there that really hadn't been put together and defined and then disseminated. And one of the things that we were trying to do was trying to figure out, well, what do we do to get there? And so we did what every good red-blooded American does, right? We Googled it. Guess what happened? Nothing. Virtually nothing. So there really wasn't anything out there. It turned out this was a pretty good picture of what reality was. But our job was to change it and make things a little bit more organized. Plus, we had kind of an aggressive timeline for doing that. I mean, after all, if NSF gives you the idea that you're supposed to come up with this definition and disseminate information about it and then turn it into educational processes and start integrating it into curriculum and restructuring education and revolutionizing all of that and then taking over the front seat in technology development in the world in 3 years, you're going to have a pretty aggressive timeline. So this was our timeline, and we looked at that and said, boy, we may have to cut back the scope of our work just a little bit to make that happen. Well, we started with the basics, and the basic thing is to try to understand what CT or computational thinking is. If we were supposed to do a whole grant about this, what would we do to make this happen? And so I kind of like Einstein, and he said a couple of things that I think were relevant here. can't explain it simply, you don't understand it well enough. Which, by the way, is really not a bad rubric to use for judging presentations like this. Okay, so if it isn't simple enough to understand, I probably don't understand it well enough. But this is time right now for a couple of disclaimers. One is that unlike a lot of people at this conference, there are over 100 of us here, I am not a computer geek. I am not a technology geek. So that's one thing that I have to admit. So what you're going to see today is a demonstration of what a normal person, other than being a dean, really I am a normal person, can do in terms of trying to understand something like this that up until now has really been sort of the purview of computer science. And I'm not a computer scientist, I'm not even close. So that's a disclaimer that I hope you'll find maybe a little bit comforting and informative as we go along. The other disclaimer is that I am a dedicated car guy. Now that may seem to have nothing to do with this, but you'll see that I kind of wander off into illustrations. Almost all of them have to do with things with four wheels. So I apologize for that, but some of you might share my passion for that, and you'll undoubtedly be overjoyed at my use of illustrations here. The rest of you may be befuddled and confused, but we'll see how that goes. Okay, so let's see if we can do this simply. I like what Einstein said about the difference between human beings and machines and computing machines, and how human beings are kind of behind the curve in terms of being able to do things quickly and accurately and all of that. But we bring the brilliance, we bring the ingenuity, we bring the questions. The computers provide the answers, but we bring the questions. Now, computers, on the other hand, really can't do anything but fast and accurate. They don't know how to ask questions. All they know how to do is take what they've been told to do and do it. Okay. Now, how's that? Some of you that are computer scientists, is that a pretty good layman's definition of what's going on here? Well, I hope it is, because that's kind of how it seems to me. And I like to think that I provide the brilliance. Now, if we think about it that way, that we're supposed to provide the brilliance, and we're supposed to connect up with computers to do the things that they can do the best, that sort of is not a bad start on thinking about computational thinking. Is how do we go from our great idea, which starts like this: wouldn't it be great if, fill in the blank, whatever it is that you want to know. Wouldn't it be great if we could find a way to measure blah, 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 and see what the impact on society would be, or the impact on education would be, or the impact on my pocketbook would be, or something like that. Now, these things are big challenges. And if we can start to kind of bridge the gap between our brilliance and the computer's ability to actually do the work, might be kind of a cool thing. Well, one of the things that we did to try to bridge this gap is we actually did bring in some computer scientists. And we found out that they weren't really that weird. They were kind of normal people that just had a sense of this thing that a lot of us struggle with. And that is, when I have a brilliant idea, how do I get an answer that goes along with that? How do I make that sing, so to speak? And one of the guys that we met, and turned out to be one of our co-PIs in the project, is a guy from Sacramento State University. And he was so normal, in fact, that he actually is kind of a camera hog. So we decided, well, if he doesn't mind being in front of a camera, we're going to film this guy. And what we did was we had him put together what we call teaching moments. And his objective, as we gave it to him, and he accepted this challenge, was to take geek speak and make it so normal people could understand it. So we had to try to break down this process that I'm talking about, the brilliance going into the actual work of the idea, break it down into digestible chunks, and we called those teaching moments. And this is what they look like. Now, we have sound, right? Speaker sound?
Yes.
Okay.
In this segment, we're going to discuss logic. So, computers obey strict...
He looks normal, doesn't he?
I'm
just kidding.
Computers have studied logic for a long time, and but computers require very strict logic at all levels. Whether you're talking about the lowest level of abstraction, the actual CPU itself, or up at the top level where you're running applications. In both cases, you need to have good command and utilize very strict formal logic because that's all that the computer can deal with. In fact,
kind of supports what Einstein said, right? That's all that the computer can do is the logical, reasonable thing, the process that a computer has been invented to do. Now, what this man's name is Scott Gordon, and what Scott did was he took a variety of components, which is our next bullet here, variety of components that are not by any means all the components of computational thinking, but he brought down half a dozen that we thought were pretty legit, pretty important, pretty much the kind of thing that we could talk about, even as lay people. We talk about those things and made these videos. Well, this is where the car guy thing starts coming in. One of the things that we were assigned to do, as the rest of the group, of the team, is to take whatever we learned from these little teaching moments and put them into modules that could be taught about each one of these components. Now, this isn't really my kind of car. In fact, I drove here from Folsom about 100 miles in a 1967 MG, so that gives you sort of an idea how quirky I am. All right, so I'm not normal, I admit it. But one of the things that we were challenged to do, whenever he would present a teaching moment, is for us to all kind of go back to our hives, wherever they were, take whatever it is that we understand, and in a sense, give some legs to what it is that we have learned. And of course, since I understand cars, I took one of the components, in this particular case abstraction, and explained it in terms of cars. So everybody know what an abstraction is? Okay, I don't want to leave anybody in the dust with my incredible knowledge about this stuff. So, but one of the things I was thinking about with abstractions, because there are ways that you can take something simple and explain or engage a complex process, is cars. Cars are just like that. How many of us know how to drive cars? My wife doesn't think so. Yeah, okay, so it is a bit of a subjective thing. Does everybody know what an engine management unit is? It's basically a car computer. Now, engine management unit manages, guess what? The engine. Yeah. Now, the more cars get sort of integrated, a little bit like what we heard this morning, as all of these processes become kind of integrated with one another, then these things tend to kind of overlap. So the engine talks to the transmission, which talks to the brakes, which talks to the air conditioning system. All of these things are in dialogue with each other. Okay? Now, can anybody explain thoroughly how that happens? Probably not. probably not anybody, except maybe an Albert Einstein type. And I'm a car guy, and I can't explain it. But I can tell you one thing. With very few exceptions, we know when we get in a car what we need to do to get that car from point A to point B, don't we? Okay? We don't know how power steering works, or whether it's rack and pinion, or worm and screw, or whatever other different kinds there are. We don't know if it's electric or hydraulic or pneumatic, or even if it's manual. We don't know, and we don't know what that means. And you know what? Who cares? Who cares? We turn the key, we put it in gear, We steer it, it goes where we want it to go. By the way, a little secret about car guys, they almost never use the phrase A to B. It's all about the journey with car guys, so I just don't want you to get, kind of mixed up on that. But here's an example of that, and the idea here is to take this to a high school auto shop class and explain the concept of abstraction to them, and then say, okay, now we're going to learn about this. Take the whole class, walk them out in the parking lot, and say, okay, you, explain the steering system on a car. Okay? Now, what happens then is that you can actually put keys in the ignition and turn it and turn the steering wheel, and people can look at the components and all of that. And as you go through different systems of the car, and you can pick air conditioning, or you can pick braking, or you can pick anything that you want. One is equally complicated, as it turns out, as the others are, and help people to understand that part of what computer scientists do is they try to make all these complex things simple so that a user can operate them. Okay? And that's why we have an operating system. But don't get me started on DOS code or something like that. I mean, my goodness, I'm not going to get anything done. But if you give me something that's been planned from the standpoint of making it accessible to users, then we've got computational thinking. And that's just one component. We also have a lot of information that I'll give you later on where to find information about the other components and so forth. But we have, we're now at this bullet. Why is it important? We have business people in our group. You know what business people do? They ask you, why is it important? Okay, they say, why do I care? Okay, great question, great question. Because you're asking them to invest in something. Invest in computational thinking. Hire people that can do computational thinking. Start to put computational thinking standards into your hiring and evaluation process. And we can tell you to do that because in education we're so good at taking stuff. No, we're not very good at that at all, right? For us, it's a lot more this kind of thing where we have to see improvement. It has to have a record. It has to show results. And so they're always saying, why is this important? So what we did was, and I think this was a great idea, and it didn't come from the educators in the group, I got to tell you that, okay, is to come up with different definitions for different groups. And that helps us to kind of capture why it's important. Because what you address in a definition, just by virtue of the fact that it's a definition, has to relate to something that people actually care about. If they don't care about the definition, right? Does that make sense? Okay. By the way, you can stop me. I know I've gone on and on, but you can stop me anytime you want with questions. So let's take a look at the educational definition. All right? I know this is kind of eye chart small here. But the educational definition starts with computational thinking as a way of describing problems and devising solutions that uses the powers of computers and computing. Now that fits in with that whole Einstein thing, right? Okay? That's the idea there. And each one of our three definitions starts with that. What differs between the business definition, the computer science definition, and the education definition is the bullets. Okay? And there is still some overlap within those. But it sort of answers the question here, which we had to do or our business people would not have come back for the next meeting. Right? Because they have standards about this kind of stuff. Computational thinking is important because, and I pulled up the education one because I think that's probably the most common footing for all of us in the room here, is education. So if, for example, if it empowers people in a world where computers are increasingly ubiquitous, I don't think we're going to argue about that, right? About increasingly ubiquitous. Okay. I might need to look ubiquitous up and see how it differs from, say, omnipresent or some other word. But It empowers people. See, we can grab that, right? As educators, we want to empower people. That's our business. Knowledge is power. Come and get the knowledge, learn the skills. We send you out into the world. You can make things happen. You can do what you want to do. Okay? At least that's what I learned. And so far it's proved pretty successful. So this is a result of probably 6 to 10 hours of hot debate about what these components should be, the components within the definitions. But what we needed to do was, and this is the business influence again, was we needed to come up with an elevator pitch. Y'all familiar with that term? Good business term. It means, you know, if you go up in an elevator and you have, I don't know, in my case, probably 300-400 floors, you should be able to explain something to somebody by the time the elevator gets to the top or the bottom or whichever direction you're going. Okay? So this is a way that we can start to develop an elevator pitch, because for one thing, it's a common definition for all of the different target audiences. Then all you have to do is remember a few of these bullets and just be able to paraphrase them and that kind of thing, and then you're good to go. Does that make sense? Okay, so that's how we capture why it's important. And you see here I've got one foot on what's computational thinking and one foot in how did we do this. Okay, and that's what I was kind of trying to explain at the beginning. But again, all of this information is going to be available to you if you want to, look into it a little bit further. Okay. There's another reason why we need to work on computational thinking is because people say this kind of stuff about computers. All right? The computer once beat me at chess, but it was no match for me at kickboxing. Computers are like Old Testament gods, lots of rules and no mercy. Well, it's funny, but in a way, it's really what people think about computers. And they don't understand, they don't want to understand, it's just, it's all this stuff. My 89, almost 90-year-old mom is always saying, that computer, just like that, like the thing just waits for her to get up in the morning and, what am I going to pull in the old lady this time? It's always something. But then this one at the end I think is real interesting. The real danger is not that computers will begin to think like men, but that men will begin to think like computers. And philosophically that's a very interesting question. But you know what? I can't think like a computer. I don't have that capability. I do have a good little anecdote about computational thinking, though, before I actually knew what computational thinking was. My son came home from his math class with the Hanoi Tower assignment. You know what that is? Okay. So very shortly into this, I thought this thing is going to be just about infinite. How many steps is it for like a 5-level one or something?
If it's recursive, it's only about 3 statements.
Well, no. This is the one. I got to think of what recursive means. But yeah, that's one of our things too. But it's like multi-thousands of steps or something like that, and it's just ridiculous. Okay, so I said, well, there has to be some way we can get on the web and find out about this. Well, there's an applet on the web. Go at any speed you want. It'll go backward, it'll go forward. You can pick how many disks there are going to be and all of that kind of stuff. And I thought, yeah, that's pretty smart. Come up with this. I still don't know the answer, but I know where to find it, which is the important thing. The other one was it was an assignment with putting numbers on a page. That eventually was a holiday assignment, so it looked like a Christmas tree then when it was all done. And I figured out how to do that with a spreadsheet. So, what would have taken 45 minutes only took me an hour and 15 to do in a spreadsheet. So I was feeling pretty good about that. But anyway, it's one of the things that we're not really fighting, but kind of trying to ease people a little bit out of some of these conceptions that they have. And one of the ways that we did that was to, again, sort of a cog type thing here. You'll have to see here that I cut and pasted, so I didn't make that up for today. Sorry about that, but I do those things. What we did was we created a wiki, and actually we created a bunch of other stuff too. But on the wiki, what we did was we took our core documents and tried to put them all together in one place, so somebody could look down through this and see there's the business definition, ed definition, computer science definition. Here are elements of CT. Again, this is not an exhaustive list, but these are the ones that we chose because we thought we could make sense out of them. Well, all right, Scott Gordon thought that he could make sense out of them to us and we wouldn't be completely lost. We might be in some of the other ones. Then we have some examples of each one. And then we have a bunch of documents. And I want to draw your attention to this for just a minute. I know you can't really see any of those, but you'll have the URL for this as well. And one of the things that we did was we tried to put together a rubric for any assignment that you would give in any kind of class in any discipline related to computational thinking and these 6 components. So we have an abstraction rubric, we have an algorithm rubric, we have a data organization rubric, we have a time and space complexity rubric, and so forth. So you might find those interesting. I thought, I might print some of those up and so forth, but in the name of trees, I decided just to give you the URL instead. But there are things that you can use to sort of put yourself through, this is what I like about rubrics, is it puts you through the mental discipline of trying to figure out what the outcome is that you want. And then trying to put it in such a way that a teacher with limited time and resources and perhaps even limited knowledge in the area can still look at it and go, oh, okay, I can assess this and this and this and this and this. All right, so that's the idea of the rubrics. And now we're going to get a little bit tipsy moving out of this because I'm on a different computer and I'm not really sure how that's going to work. All right, full screen, and there we go. Okay, so that's coming your way here in a minute or two. Finally, the thing that I want to really emphasize in this whole deal is that and I'll just speak for myself. I'm not particularly smart, especially about computer science. I don't have any magic answers. I can't do everything myself. I found that out. Although my wife still kind of thinks that I should. Well, anyway. But there are all these sort of limitations that I bring to the table, and each one of the people that got involved in the project also has limitations. Some of them just don't understand education. Why do you think it takes so long? Stuff like that. Some of us don't understand business. But one of the things that we decided that we would really put an emphasis on is getting people in the room and kind of sloshing together all the strengths and weaknesses and seeing what we came up with. And one thing that we decided we had to do was get our K-12 partners involved. We had to do that somehow. We had to have a strategy for that. So we went to our K-12 partners and said, look, what's in the way? And they said, oh, well, that's easy. There's 2 things, standards and frameworks. You talk to us about doing anything different than what we're already doing, we don't have time, period. Okay, who should we talk to? Well, there are these crazy engineering people in our schools. They're part of a project called Project Lead the Way or something like that. Now, nobody really understands what they're doing, but they seem to have a lot of fun. And right away, that's not one of my weaknesses, is being able to find fun. I can find fun. So we start talking to these people, and they say, yeah, we have fun. Well, how do you do that? Well, we have this this Project Lead the Way thing that we do. It's an optional class in middle school and high school. How many of you have heard of Project Lead the Way before? Okay, yeah, so it's out there. It's been out there for a while. But the really cool thing about teaching this is that we don't have standards and frameworks that we have to work with. We can do it the way we want to do it. And you know what happens with that? No big surprise. The rigor goes up, not down. The expectations go up. Guess what happens with performance? Goes up. The excitement, the passion, up. Again. All right. The resistance from administration, up. No, they're actually pretty good about it. But so we started talking with these people, and we discovered that they were not just willing to talk about computational thinking. They were already teaching it. They just weren't calling it that. They were doing all kinds of projects that were really, really cool, and the students were loving it, and yet they were a little bit weak in terms of their evaluation of it. So we brought our rubrics in, and they said, ooh, rubrics, we like rubrics. We do rubrics all the time. In the community college realm, we don't do rubrics until it comes to SLOs, right? And then we start getting all rubric. But anyway, what happens is they come in for a day, and they're going to help us work on some projects. Now, we had turned out some mighty modules, like that one I just showed you that I did with the car and all of that. Okay, so I got that sucker done in under a month. Okay, when I worked really hard on it. We had 6 teachers come in for a half a day, and they turned out 8 modules. They just busted them out. And we're like, what? What is going on here? You know, it was just because they were so excited about it. And they didn't have to be told, take what you're already doing and start looking at it like computational thinking, and this is all going to fall together. We didn't have to tell them that. They knew that already. They knew it instinctively, because that's the kind of teachers that they are. So, I'm going to show you some of them here. This is a conference that we had. This is long after we had them in to do modules. It's a conference that we had to introduce some other Project Lead the Way teachers to computational thinking and bring in their principals and superintendents and folks like that. And the fellow in the red sweater there is our K-12 coordinator for the grant. And he's getting them lit up about computational thinking. These 2 guys that are in the picture here, this guy is a business guy that taught us how to do strategic planning. Did you ever hear of that, strategic planning? That's that thing that for educators takes a year and a half, 2 years maybe, to turn out a 3-year plan. Okay, we did it in 3 months, meeting 2 hours on Fridays, twice a month. Okay, so we got a lot of benefit from this guy, from his processes. The things that he brought to the table were really amazing. Kind of like the fellow from Facebook was talking about this morning, about all the things that they learn and the things that they're expected to know, and then there's things that they in turn expect their applicants to know and be able to do and all of that. Well, this guy brought all that stuff and just dumped it on us and said, hey, we got to sort this out. Okay, so he's been a real player, and then this fellow over here is one of our business professors, but he has a great background in actually doing business, and so between the 2 of them, they've kept this operating like a business, and I think that's one of our secrets too, to be able to operate more like a business. Then finally, this fellow right here, great story about him. He's one of our PIs. And he's always been the kind of guy, since I've been there in 7.5 years, that sort of sat in the background, didn't really want to get too involved. He's a good faculty member, but you give him a form to fill out, and you just draw a little line in each of the places where you're supposed to give more than a 1-word answer or check a box or whatever. Kind of hard to figure him out, hard to get him motivated. CT lit his fire. And you can see what's going on here? And he's with a bunch of strangers, and he's really going for it. So I think that's one of the great unanticipated outcomes of doing something like a grant. Because one of the things that I always say, and I've got a long grant history, much longer than my dean history actually, one of the things I always say is if you want to do anything innovative, if you want to do anything that's exciting or that reflects your passion, you are not going to find a budget line for that. You know, I do not have innovation, experimentation, or any other really fun-sounding budget lines. It's all just nuts and bolts. So you have to go out and look for some money to do the stuff that you really want to do. So that's what we did, and I think NSF's a really great place to kind of get started with it. And that's about all I want to say, except to tell you that I really like computational thinking. I'm having a lot of fun with it. And I'm a psychologist. I deliberately didn't tell you that until the end. But they're definitely not a computer scientist. So what I'm going to pass out here is kind of a cheat sheet of what our resources are that are out there for you, if you have an interest in looking at those some more. Also, if you'd like to give me your card, I'll put you on our list, and you'll get information about new things as we're developing them and so forth. And I have about 5.3 minutes.
Gary, do you have a website or a link that you want to share with anyone that might be reviewing this online?
Oh, yeah. Let's see. Yeah. Yeah, if I go... Are they seeing this? Mm-hmm. Okay. What I'm going to do is I'm going to go backward to our wiki. So we have a Facebook page and we have a YouTube channel and a bunch of other stuff. Where'd I go? Oh, okay, I know where I am. See, this is a problem with being a dean, is that you could get confused over the most mundane things. Okay, that's the one right there. So if they can grab that, we're good to go. Anybody have any questions, comments, snide remarks? all are welcome. Yes.
Actually, I don't think I had a chance to ask you about this last time. The psychology of teaching. I'm kind of interested in how that aspect is developed.
Well, yeah, that is really interesting because I think we haven't really dealt with that yet. What we've dealt with more is kind of the psychology of resistance to it.